Welcome everyone. Now I'm going to solve choice of A, and it's asked us. Let's read the question. Two parallel plate capacitor. C1 is 4 microfarad, C2 is 8 microfarad, are connected in parallel combination if the total stored charge of group 600 microcoulomb when they are charged by a continuous voltage source. When they are disconnected from battery, so that means before disconnection, total charge is equals to 600 microcoulomb. I calculate the charge 1 and charge 2 and stored energy 1 and stored energy 2 for the capacitors. And let's calculate. Firstly, to calculate charge we need capacitance and potential difference. And calculate charge 1, I need C1, I need V1, I don't have, so I have to calculate V1. And how can I calculate V1? V total is equals to V1 and V2 because they are parallel. So V total is equals to Q total over C equivalence. This comes from this formula, and so I have to calculate C equivalence. C equivalence is equals to 4 plus 8 is equal 12 microfarads, and Q total is given 600 microcoulomb over 12 microfarad. There is micro and micro, they cancel each other, so the result will be 50 volt. This is the potential difference before inserting dielectric. So now I can calculate the Q1 is equals to C1 times V1. C1 is equals to what? 4 microfarad. 4 times 10 to the power of minus 6 times V1 is 50. So it will be 200 instead of 10 to the minus 6 microcoulomb. And Q2 will be C2 times V2. C2 is 8 microcoulomb. 8 microfarad, 10 to the minus 6 times potential difference, same as the potential difference of the battery, 50. So it will be 400 microcoulomb. And potential energy, stored energy for the first one, half C V square, C1 times V1 square, half times, what's the C1? 4 times 10 to the power of minus 6 times V1 is 50 squared, and this is equals if we multiply by it, we will get 4 over 2 is 50,000. 50 squared is equals to 2,500. 2 times 2,500, 5,000 times 10 to the power of minus 6 joule. Stored energy for the second one is equals half C2 times V2 squared is equals half times C2 is 8 times 10 to the power of minus 6 microfarad times V2 is 50 squared. So the result will be 10,000 times 10 to the power of minus 6 joule. This is the solution for the A. What about the B? The B says to us, when the dielectric inserted the second capacitor, calculate C1 and C2, Q1 and Q2, delta V1 and delta 2, delta V2 potential energy first one and second one. Calculate them after inserting dielectric, which is the dielectric constant is equals to. So after inserting dielectric, we must calculate the potential difference again. Why? Because the battery disconnected. So now let's calculate the C2K. It's equal to K times C2 is equal 2K is the 2 times C2 is 8. It's going to be 16 microfarad. And C, we will obtain C equals K, C1 plus C2K. So C1 is equals to 4 microfarad plus C2K is equals to 16. So the result will be 20 microfarad. And to calculate potential difference, we need to calculate potential difference again. Why? Because the battery disconnected, and we insert the dielectric. So its capacitance change. So that means total capacitance change. With the total capacitance change, potential difference will be change. So delta V total is equals to Q total over C equals K. And Q total does not change. Why? Because battery disconnected, it cannot get more charge. So it's equals to 600 times 10 to the power of minus 6 over C equals K is equals to 20. So the result will be 20 times 10 to the power of minus 6. Result will be 30 volt. It's asking the capacitance C1. C1 is equals to same amount 4 microfarad, but C2 will be 60 microfarad. We calculate this, and now V1 and V2 they are equals to each other. So 30 volt will be equals V1 and V2. So we calculate this, and now we have to calculate Q1 and Q2. Storage charge 1 and storage charge 2. Q1 is equals to C1 times V1. C1 equals 4 times 10 to the power of minus 6 times V1. We obtain a new potential difference because the dielectric inserted 30. It will be 120 times 10 to the power of minus 6 coulomb. And Q2 is equals Q2K actually is equals C2K times V2, and C2K is equal 16 times 10 to the power of minus 6 times potential difference same equal to each other 30. So it will be 480 times 10 to the power of minus 6 coulomb. And the total charge must be equal sum of the all charges. So Q1 is 120, Q2 is 480, so it will be 600. 10 to minus 6 means microcoulomb. So total charge 600 microcoulomb. So we are correct. Let's calculate the potential energy first and potential energy second. Half times C1 times V1 squared. It will be half times C1 is 4 times 10 to the power of minus 6 times V1 is 30 squared, and 4 over 2 is 2, 30 squared 900. It will be 1800 times 10 to the power of minus 6. We calculate the energy, so the unit must be joule. And potential energy, stored energy, second one, but we insert dielectric, we can write there a K to show that, to indicate that half times C2K times V2 squared is equals to half times C2 is, we calculated 16 times 10 to the power of negative 6 times V2 is 30 because it's parallel combination. So in parallel combination it is the rule potential difference, all of the potential difference are equal to each other. 16 over 2 it will be 8, 30 square 900, so 8 times 900 7200 times 10 to the power of minus 6 joule will be result. Thanks for your listening.